Let us humble ourselves for out of prayer. Heavenly Father, we thank you for today. Thank you for the mercies that are new every morning. Thank you for allowing us to meet at this time to have our lesson. Pray that whatever that you are going to teach, we are going to pick and we are going to understand and shall remember it, and that we shall not forget. And when the time comes, we shall apply it well. In the mighty name of Jesus Christ, I've prayed. Amen.
Amen. Thank you so much, Joseph. Today we are going to continue with our calculations. Last time, our focus was on calculating what we called the force. We're looking at how we calculate the force on any given charge. And today, we looked at how we can calculate the resultant force when you're given any charges in space or in air. But today, we are going to look at now the second thing, what you call the electric field intensity. Those who have tried to look into the UNEP papers, I am very sure you have not missed seeing numbers that require you to calculate the electric potential, numbers that require you to calculate electric field intensity whenever it comes to that section of electricity. And also when you look in many of the papers, you'll find that such numbers that require you to calculate electric potential, electric field intensity do not miss. Why? Such numbers, they do not miss, and always they carry 4, 6 marks. And these are the numbers that we should always have to pass if we are to get good grades when it comes to that part. So that is the section that we are going to still continue with, such that by the time we go back, we have really mastered that section. So this section is what we are going to handle. And today we are mainly going to focus on what we call electric field intensity or electric field strength. So our area of concentration is going to be on this part we call electric field intensity. It doesn't matter whether you have covered this topic or not, whether you have reached this part or not. What matters is for you to understand what we are going to do and also to learn it, because I know some of you might have covered it, some of you maybe you have not yet covered it, but it doesn't matter whether you have covered it or not. The concept remains the same, and by the time you reach there, then for you to be just a walkover or to just be revision work. Now that is our area. We are going to mainly look at calculations, but before we look at calculations, we need to know what is electric field intensity. Now, when they talk about an electric field intensity, we are looking at the force that is existing between the charges placed in an electric field. Whenever you have a charge, let me say this is my charge, Q1, and this is my charge, Q2. When they talk about an electric field intensity, we are looking at the force that is being experienced. But here we are considering that that charge has a positive 1 coulomb, meaning that if at all I'm looking at charge Q2, it means that it has a charge of 1 coulomb. So the force, the electric field intensity that is experienced by charge Q2 due to charge 1, it means that one of those charges will have a positive 1 coulomb. In case you want to find the electric field intensity acting on Q1, it means that you are going to find this Q1, the one that they are acting on, it will have a charge of 1 coulomb. So what is very key is that electric field intensity is that force that is being experienced by a positive charge. We know very well that when we are calculating force, we say that force will always give us, you get your charge 1, you get your charge Q2, K out of our R squared. But now when it comes to electric field intensity, one of these charges will have a positive 1 coulomb. So meaning that where there is one of these charges, you just put 1, meaning that your force will be Q charge out of R squared. But this force here is like when you multiply times 1, the force remains the same. So you get KQ out of R2. Now, this force here is a special force. And this special force is what we are calling electric field intensity. So that means your electric field intensity is the same as K charge out of R squared. That is what we call electric field intensity. So when we ask what is the electric field intensity, we say electric field intensity is that force that is experienced by a positive one coulomb that is placed in an electric field. And how do we get it? You can easily even say that to get electric field intensity is the force per unit charge, is the force divided by charge. We know very well that when we are obtaining our force is given by K, charge 1, charge Q2 out of the charge. Out of R squared divided by N charge. So in case this charge is maybe charge 1, then that means they'll cancel out and still remain with Q2 out of R squared as our electric field intensity. So electric field intensity means force per unit charge. So when you are asked to calculate electric field intensity, that means that electric field intensity is given by this formula. The difference between electric field intensity and the other force that we calculated last time is that for it, you will only have one charge. And you don't have the second charge. The second charge is the one that is contributing to the one coulomb of charge. Members, are we together on that? Is that
Yes.
okay? Has everyone understood that?
Yes.
Okay. Should we continue?
Yes.
We can continue. Okay. Now, what do you need to know? You need to know that the SI units, what we call SI units, how are they going to come about? To obtain the SI units of electric field, we have said that electric field is given by the force per unit charge. What are the units for force, members? What are the units for force?
Newtons.
It is newtons, divided by what are the units for a charge? Is given by what? A coulomb. Yes, so meaning you have Newton out of coulomb, which we give it as Newton per coulomb. So the units for electric field test is Newton per coulomb, or at times you can use volts per meter. They are the same. So you can use any of those two. Are we together?
Yes.
Okay. Are we good to continue? Can we continue? Okay. And now we are going to look at our first example. Now, when you look at our first example, they're asking us that find the electric field intensity acting at point P. Now, remember, electric field intensity is a vector quantity, is a force. And you know that forces have directions. Now, you need to know which forces are acting on P. Electric field intensity being a force, we say that in charges, you can either have an attractive force or you can have a repulsive force. When you look at now I'm going to find the electric field intensity acting at point P due to charge 4. That is what I'm going to be obtaining. Electric field intensity at point P due to charge 4. That's what I'm going to find. Now, what am I going to say? We said electric field is given by K. You can put the charge divided by R squared. And we know very well is that K is given by 9 exponent what? 9 times the charge, which is now 4 times 10 power negative 6 divided by the distance from where 4 is up to where we have our P. So members, which distance do you have from 4 to P? Which distance do you have from 4 to where P is?
7 centimeters.
It is 7 centimeters. But what are the signs? What are we going to do? Do we write centimeters or we change to meters?
Change to meters. 7 times 10 to the power negative.
So what shall we write down here when you change?
To be 7 exponent negative 3.
Negative 3. Sure. Is it negative 3?
Negative 2.
Negative 2. Very good. Kindly check out squared. So members, can we get that answer? Can we get that answer? So those who don't remember how to convert, you go back to this primary thing. King Herod died, I think many dogs cried much. So from centimeters to meters. So you divide by 100. Okay, members, can we get the answer here now? Let me check in the chat whether we have the answer. You place in your calculators and then you get the answer. And don't forget that on your calculator, you can place this everything the way it is at once. On your calculator, those who are using Casio, maybe 991, you just place 9. You place 9, then you go on your calculator near answer. There is this thing. There is a button with this letter. So you say 9, you place shift, you place 9, you place that sign, you get 9, then a small e there, then you just put 9. Then you say times, you say 4, place that thing, e, put negative 6. Then all of it, this one must put in bracket, then you say divide by, you put brackets 7, e, negative 2, everything squared. You'll get the answer. Okay. Joseph is saying, Joseph, can you give us that answer in a standard form? Your answer is okay. Tuishime is saying 7.35 exponent 6. Okay. 7.35 exponent 6. And we have said the units are Newton per column. Members, do we have that answer?
Yeah.
Okay. Now, electric field intensity being a vector quantity, we have already stated the magnitude. So we are going to get the direction. And how do we get the direction? The direction, it depends. Like we want to find a force acting on P, the electric field intensity. But remember our assumption or our definition says that this P is always a positive 1 column. So now this is a positive and this is a positive. So which kind of force is between the two charges?
Repulsion.
Repulsion. Very good. So being a repulsion, this one is going to be like this, like you have a positive and you have a positive. So meaning this one will pull this side, this one will pull this side. So the force, this is your P and this is your positive 4 microcoulomb. Since we are finding the force acting on P, it means that this is going to be our direction. So the direction between the 4 and the P is going to be this direction. And which direction are we going to say? We are going to say 7.35 exponent 6 towards the right. Is that clear, members?
Yes, teacher.
Okay. Okay, good. Now we are going to continue. Then we are going to find the electric field intensity acting at point P due to the negative 6. Still, we shall say K, magnitude of charge, divided by R squared. So we continue and say 9 exponent 9 times our charge, which is 6 times 10 power negative 6, divided by. What are we going to divide with down? What is the distance between the negative 6 and P?
2 times 10 to the power negative 2.
2 times 10 power negative 2, then squared. Okay, members. So those who have just joined, who have not yet done this topic, we are taking it 6 because of this magnitude. This magnitude absorbs any negative. So you can never get your answers negative. The negative is taken away by the magnitude. So place your calculators and you get the answer. Someone is posting in the chat 4 exponent 6. Okay, that's what someone is saying. Okay, let me hope you have squared down. Try again. Joseph is saying 1.35 exponent 2. Okay, I think you need to try again. Members, are those the answers we are getting? Let's try. Another one is saying, 2 is saying 1.35 exponent 8. Now also let me place on let me see what I'm getting. And I see which person am I going to agree with. Yes, placing a calculator is also a skill. So I'm agreeing with Tui Shimi. Yes. So members, Joseph, check out. Really me, check out. I'm also getting 1.35 exponent 8 Newton per coulomb. Okay, really me has also accepted. Okay, now that is good. Now, after obtaining, the next thing you are going to look out is the direction. Now, when you look at this force is a negative. This one is a positive. So it's like you have a negative near and a positive. So I have here my negative. I have here my positive. At P, I have negative 6. So negative and positive, which kind of force do we have?
It's an attraction force.
An attraction force. So our arrows will be pointing towards each other, that they are attracting each other. But since we are looking at P, what is the direction of the arrow at point P of the force? Which side is it pointing?
The left.
To the left. So we are going to say towards the left. And now that's going to be our answer. Members, is that okay? Now, we are going to continue and get the resultant electric field or the total electric field intensity. Now, to get the total, I have to get this one due to the 4 charge, and I get this one due to the negative 6 charge. Then I add those two things. After adding, I'll get the answer. So when I look at this 4, this one is to the right, and this is towards the left. And we say that when something is pointing to the left, you consider that thing as a negative. When something is pointing to the right, you consider it as positive. So my total electric field intensity is going to be 7.35 exponent 6 minus, or you can say, because we are adding, so you say minus 1.35 exponent 8. Members, what do you get as your answer? What do you have as your answer? Subtract those two and share with me which answer you have. Okay, someone has posted something. Negative 1.28 exponent 8. Okay. Now I'm going to ask Joseph. 1.27. You are saying that your answers are a bit similar, but they are not the same. That means that you have rounded off from the calculator. Now, that is what I told you. Always avoid rounding off from the calculator. Always first write at least, after the decimal point, write at least write at least 3 or 4 figures. Then you can go on and round off. Because here you are missing out on the accuracy. So you can first write it as you are getting it. 1.275 exponent 8. Then you say these are newtons per coulomb. However, now here we are going to make a conclusion. When you are writing your electric field intensity, it can not be a negative. Whenever you find there is a negative is just an indicator that you are moving towards the left, that the strongest force is taking you towards the left. So here our answer would be, your conclusion would be 1.2765 exponent 8 Newton per coulomb towards the left. So you drop the negative and you substitute the negative with the direction, because negative shows the direction. Members, how to get on that?
Yes.
Okay. So finish the writing and then we continue. Okay, can we continue now? Okay, someone saying we can continue. Okay. So we have another number here, still asking us to find the electric field intensity. So I'm going to ask everyone that you are going to calculate. We are going to find what is the electric field intensity at point A due to point A. So I want you to calculate, get that. So members, we are going to calculate. Go through the same procedures. Electric field at B due to C. Go through the same procedures. Your charge, now you want the electric at this point B, but due to the charge A. Then due to B, due to the charge C. So can we try it? Or can I have someone to tell us what to write? Anyone who is willing to take us through? So welcome. Who wants to take us through? Okay, so find a force as I also make the calculations. Then get your answers. Get your answers. Okay. Hope we are obtaining the answers. Anyone who has got any answer, share with us. In case you have got any answer. Okay. Riomi is saying is getting 4.5 here. Exponent 6 Newton per coulomb. And this side is getting 1.0 times 10 power 7. Okay, that is according to him. The rest also get yours. Okay, 2 is saying 4.5 exponent 6, 1.08. Okay. He has added on something. He's saying this is not right. He's getting 1.08 exponent 7. Now, I've not seen anyone mentioning the directions. Can you also go on and mention the directions? Mention the directions. Which direction is FBA and in which direction is FBC? Mention the direction. Of those forces. Yeah. Both towards the right. Both toward to the right. Good. So I'll say this towards the right, towards the right. Okay, this is good. Now we are going to get the effective or the effective or the total. So meaning the total, you just add up add the two since all of them are pointing in the same direction. And let me check what you have obtained. What have you obtained now? Someone told us the total was 1.53 exponent 7. That was Joseph. Joseph, I want you to first go and see. That was Joseph. Okay. Okay, I'm waiting now for the total. What are you getting?
Excuse me, teacher.
Yes, please.
Teacher, could you explain more on the direction bit?
On the direction. Okay.
Yes.
Which direction do you want for?
Teacher, both.
Okay. Okay, you stay on. What is the charge on A?
Positive.
A is positive. What is the charge on B?
Teacher, B is positive.
Why?
Teacher, I'm not sure.
Yes. Now, since we are finding electric field intensity, we say that electric field intensity is that force that is experienced by one positive charge. So that's where it comes from. So whenever they tell you to calculate electric field intensity at that point is always positive. Are you getting it?
Yes, teacher.
Yes, so that's why it is positive. Now, a positive and a positive, which force is between the two?
Repulsion.
Yes?
Repulsion.
Repulsion? Repulsion. So how does the repulsion? Repulsion means like you are pulling away. So it means that
Yes.
this is going to be pulled this side, this one is going to be pulled this side. Not so?
Yes, teacher.
Yes, but since we are interested in electric field intensity at point B, we look at the direction of that arrow. So which direction is that?
Towards the right.
Towards the right. So that's why they are getting it. Now
Yes,
come
teacher.
back. Let's do B and C together. What is the charge on B?
Positive.
The charge on C?
Negative.
Negative. What kind of force is between these two?
Attraction.
Attraction. And how does the attraction force act?
Towards the right. Towards B.
So they are going to act like that, not so?
Yes.
They are going to pull each other. Now, since we
Yes.
want electric field intensity at point what?
B.
So you look at the direction of that arrow. So which direction is it facing?
Towards the right.
Right. So that's where it is coming from.
Oh, thank you, teacher.
Okay. So let's check. I'm getting the final answers this. Newton per column. And since it is positive, I will say towards the right. Members, let me know whether it is very okay. Toy, that was good. Members, is that fine? Let me know whether it is clear. Okay. 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 Should we continue? Has everyone finished? Feel free to unmute and you tell us. Has everyone finished such that you can continue? Okay. Ocean is saying yes.
Proceed.
Okay, we proceed. Okay. Now we are going to at least now let us look in the question bank and try out some numbers again in the question bank. Now, when you look in the question bank, it was question 9. So it is like this. And here there is positive 6.4 microcoulomb. I have another force here, which is negative. I have another force here, which is positive. And I have another force here, which is P. So from here up to here, I have 0.5 meters. Always be very careful the questions. From here up to here, yes, Maska, Brian, I have 0.2 meters. Maska, Brian, and from here up to here, Maska, Brian, unmute, I have 0.3 meters. And the question is asking us, three-point charges arranged in line as shown in figure above. Find the electric field intensity at P. And this question had 6 marks. Okay, so we are going to continue. But I don't know, but I want us to participate. Can we have one person first take us through the first part like that? I don't know if that is possible. The first person to tell us the force at P due to the 6.4. Then we can have another person to tell us the force at P due to the negative 6.4. Another person to tell us the force at P due to the 3.2. Okay, who wants to lead us? The first one. Okay, let's calculate. Let us first try it out. Yeah, let's first try it out. Everyone, try out those parts. So we are calculating. Those who have just come in, we are calculating. Calculate. We are trying out. And please be very careful that the distances are given in meters. So there is no need for you to do double conversion. For the first force, 6.4, what is your distance, R?
Teacher, 1.
1, very good. So you say 1 squared. So which answer do you
Yes.
have?
5.76 exponent.
Okay, 5. Yes, real me. You have 5.76 times 10 power.
4.
Okay, Newton per column. Real me, what is your direction?
Teacher, towards the right.
What's the right? Why?
Because charge, the positive charge at P repels with the positive 6.4.
Okay.
Yeah,
Okay.
and so when we are considering the direction, we consider at P.
At P.
So it will be at right.
Okay. Okay.
Yeah.
Are you with someone there?
Yes.
Does she also do physics?
Yeah.
Okay. Can she also take us through this second part?
Okay. Okay, teacher. So teacher, it's going to be 9 times 9 exponent 9 times 6.4 exponent negative 6 divided by 0.5 squared. Teacher, let me calculate the answer. Teacher, the answer is 230,400.
Or give it
Meters per
in scientific form.
Yes,
You
teacher.
can give it in standard form. Standard form.
Standard form. So it's 2.3 times 10 to 10 to the power 5.
So what is your direction?
My direction is teacher towards the right
Why?
because they attract each other and we are considering the electric field intensity at P.
At which point?
At P.
At P. So which direction is it going to be taking?
So towards the right.
Sure. Which kind of force is between the two?
Yes, teacher.
Which kind of force is between your negative 6.5 and the P?
So it's negative and positive. So so it's towards the left.
Why?
Teacher. The direction of P is positive. So it's going to attract.
And remember, when they're attracting, this one will be like this one will be like that. So this is left. Okay.
Yes.
Okay. Do you have another person with you?
Teacher, we are 2.
Oh, okay.
Yes.
Okay. We can continue the rest. Let me hope we are following. Okay, Joseph. Okay, Joseph. Okay. Joseph, check out your direction for the 2.3.
I got my directions inverse. I was using the other points, but it's the resultant is to the right.
Oh, okay. So your directions, all of them are not right. Oh, Joseph, are the directions right?
No, they're all vice versa.
Okay. Okay. What has brought that?
I was looking at the directions from the perspectives of the actual charges, not from point P.
Oh, okay. 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 Now, I hope you have got that, what you need, what you are supposed to do.
Yeah.
Okay. Okay. So please you just check whether that is what you have. I've seen some answers from Tui Shime. Okay. So the resultant so you add all those ones to the right, and then those to the left, you just subtract them. Oh, Riomi, we are still on the same track.
Yes, teacher.
Okay. 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 Joseph, hope you get your answers somewhere close to this.
Yeah, it's the exact same one. The issue was the direction.
Oh, okay. Okay. Members, let me hope it is okay now. Can we continue, or people are still writing?
Sorry, continue.
Okay. We can now continue. Okay. So we are going to look at another number in another format. Now, still, we are going to try out a question bank number. question bank number. That is my figure. And when you look at my figure, I'm going to call this point Q. Okay. And this is going to be point R. And this point R is equal to positive 3 times 10 power negative 9 columns. Q is positive 4 times 10 power negative 9. And this is 4 centimeters. This is 3 centimeters. This is negative 3 times negative 9 columns. So this is point P here. And then this is point S. So I can write the question. Three charges of negative 3 This question was of 7 marks. But there are some 3 marks that are always for you to get directly by making those simple calculations. And those are the marks that I want everyone to first look for from this question again. Yeah. Let's move if one has finished.
Teacher, not yet.
Oh, okay. Okay, thank you for the correction. This is okay. Yeah. Have we started making some calculations?
Yes, teacher.
Okay,
Yes,
very good.
teacher.
Okay, perfect. I want to remove this. Let more people had finished writing. So those are the first ones I'm going to wait for. Those are the first few marks I expect everyone to get. Nice. Can I start with someone who wants to take us through first? Okay, I choose Ready Me. Real Me? Yes, I think. Real Me?
Yes, teacher.
Yes, be the first to take us, then Dennis or Chen will take us. Tell us FSR or FSP. Choose one that you have finished.
Teacher, SP.
SP,
Yeah. So it will be 3 exponent negative 9
Okay.
times 9 exponent 9
Okay.
divided by 0.04 squared.
0.04
Squared.
SP. Okay.
Yes.
Good.
Squared.
Continue.
Then, so let me capture the answer. So the answer is 1.6875 exponent 4 towards the left.
Towards the left.
The
Why?
left. Because we are calculating the electric field intensity at S, and at P, we are having a negative charge, whereas S has a positive charge. So they will attract each other, but considering the direction at S, so it will get attracted at P towards the left direction.
Perfect. Thank you so much. Okay.
You're welcome.
Yes, Ochen. Ochen, which one do you want to take us through? Unmute. Unmute. Okay.
Yes.
So which one do you want to take us through? Yes? Okay, let me... Ochen, have your video off. Have the video off such that you can talk and we hear very well. Okay, Ochen, now you can talk. Ochen, your network is not so clear. Okay, do we have any other person who wants to take us through? Ochen, thank you, just because your network is really disappointing.
Teacher,
Okay.
Considering electric field intensity at S, but with RS.
Okay.
Yes.
At S due to R. Okay.
Yeah. So teacher, it's going to be 3 exponent negative 9 times 9 exponent 9 divided by 0.03 squared.
Okay.
So the answer is going to be 3.0 times 10 to the power 4.
Okay. Your
Yes.
direction? We are waiting for your direction.
Yes, teacher, I'm getting the day.
Okay.
Teacher, when you're setting
Yes.
direction, is it necessarily going to be left and right? Or I can say,
When you look at the
teacher,
clouds, what do we say?
the clouds
When you look to the clouds.
upward.
So also those ones can be directions.
Oh, okay. So it's going to be upwards.
Upwards. Good. Yeah, that is correct. Is that okay? Yeah, thank you. This is correct. So remember, members, your direction can either be left, right, up, downwards. Also, those are correct directions. Okay? Or vertically upwards. Okay. Okay. We continue. Joseph. Joseph?
Yes.
Yes. Can you take us through? Okay, Bujo. Bujo, did you want to take us through? Let me first ask Bujo.
Teacher, I have a question.
Okay, yes, Bujo, first ask.
So how about if I don't put the directions there, then at the end of it, or when I'm getting the magnitude of the resultant, it's when I input the direction. Will they penalize me for, like, will it reduce on the marks that the first marks that I'll get, or it's going to be the same thing?
Okay, now it may depend on the marking guide. Someone may say that maybe they'll give the final answer and the direction. But to avoid, maybe even at the end, at times students tend to forget them. Though they may not penalize you, but I want you to have it as part of your culture. Because you know that you are stating a force, so a force must have those two components. It must have the magnitude and the direction.
Okay, sir, thank you.
Okay, yes, Joseph, take us through the last part. The force. Yes, B to Q.
B to Q. So when we're finding G to Q, it's going to be K times the charge at Q times the distance, divided by the distance of separation squared. Now the distance of separation, we're going to get it using Pythagoras theorem. That's going to give us 5.
Okay.
Yeah.
Okay, everyone is seeing the 5.
5 centimeters. So we shall have 9 exponent 9. Yeah, there. Yeah, 9 exponent 9 times the charge at Q, which is 4 times 10 to the power negative 9, divided by 5 times 10 to the power negative 2, squared. Yeah. The answer I get is 1.44 exponent 4. But then we need to find the direction. This is a positive force. Q is a positive charge. S is also positive. So S is going to be repelled in that particular direction. So we would draw axes to get, we need to get that the angle between the horizontal and that line. of
Okay.
action of the force.
Mm.
Yeah. So we draw those
Okay.
axes,
Mm.
and we know that it's
Okay.
acting upwards.
Let me draw.
The positive sides of the axis.
Okay. Let me draw.
Yeah, like that. Then it's acting at some angle there. Exactly. And
Which angle do we have here?
the angle I get is 36.9 degrees.
36.9. And let me ask you, maybe leaving some people behind. Is everyone getting where we are getting 36.9? Members, are you getting where we are getting that 36.9? Okay. Rio, me and your sister, are you getting where we are getting that angle?
Yes.
Okay. Okay, perfect. Let's continue. Joseph?
So we should now write this force in vector form.
Mm.
We get the horizontal component
Mm.
and the vertical component. The
Okay.
horizontal component being 1.44 times, 1.44 exponent 4.
Mm.
Then cos of theta, which is 36.9, and that's going to be 1.15 exponent 4.
Okay.
1.15 exponent, yeah, that.
Okay.
And that one will be sine.
Okay. So we end up with
1.15 exponent 4.
1 point.
1.15 exponent 4. And 8.64 exponent 3. Yeah.
Yeah, thank you so much. Members, are we on that step, everyone?
Yes, sir.
Okay. Can we continue and get the resultant? Can we get the resultant? Add all those forces you have that are pointing in the same direction. And have those forces that are pointing horizontally added together, those pointing vertically added together. And then, in case you get your answer, you can type in the chat and you compare. You can type your answer in the chat and then you compare. You can put your forces in the chat and then we compare. Add. And then you get to know what you are getting. Okay, Dennis Ochen is saying his resultant is 3.9 at an angle of 82.1. Okay, thank you, Dennis. So members, confirm that you have your resultant. Your resultant should be negative 5.3550 exponent 3. Then your y is 3.8640 exponent 4. Members, do we have that? Is everyone having that answer of that nature?
No, teacher.
Yeah?
Teacher,
Yes.
could you go back? How did you get the 36.9?
36.9.
Teacher.
Now I come back to this triangle. Are you seeing this triangle?
Yeah.
Yes, teacher. Wait.
Which angle do you have here?
So we had 40.9.
Here you had
40.9.
40.9, yeah?
No, teacher, we didn't. The angle was at Q.
Okay, the angle.
40.9.
This one what?
40.9.
40.9, yeah?
9. Yes.
Okay, let me just confirm.
Okay.
What did you use to get that 40.9?
So we use tan.
So what did you say tan of? Theta is equal to? Tan of theta was equal to?
Teacher, 3 out of 4.
3 out of 4. So what did you get for your tan inverse of 3 out of 4?
Teacher, 40.96, but then it's going to be 41.
Sure. Place your calc. Things
Shall
your
we
calc
press?
has a problem.
Okay, teacher.
You place tan inverse of 0.75. What do you get?
Teacher, we get 40.96.
Okay,
Then
now you place shift.
Yes, teacher.
Mod.
Shift mod.
What are you getting on your screen?
V1 MCL2 mod 3 or
Place 3.
yes,
teacher.
Place equals.
Yes, teacher.
Place on.
Yes.
Now you place tan inverse again of 0.75.
0.75. 36.86.
So you're getting 36.9.
That is the answer. So your calc was in I think it was in radians.
Oh,
yeah.
Okay, teacher. Thank you, teacher.
Okay.
Teacher, but then also, how do you get the total electric field intensity?
Okay. Now to get it, we are going to add all those we have along the x.
Yes.
Now, when you look at this is your ASP. Are you seeing it?
Yes.
But you said ESP was pointing to the left, this side.
Yes.
So now if I thought it's pointing to the left, it will be negative. So I'll say negative 1.6875 power 4. Then I look at this one. When you look at this component here, it has the x component, this, this now. So it is positive. So I say plus 1.15 times 10 power 4. Is that okay?
Yes.
Then we get
Yes.
then I go to EY. EY, this one is pointing upwards. Upwards means a positive direction. So I write 3 times 10 power 4 plus.
Yes, teacher.
This one is also positive. I write 8.64 times 10 power 3. I get the answer.
Yes.
So that's how we are getting it.
Oh, thank you, teacher.
Okay. Should we continue?
Yes, teacher, we continue.
Oh, where did that screen? So now to get our resultant, the magnitude, just get the square root. Just get the square root of that. Just get the square root of this. Get the square root of that. I don't know what we are getting. Joseph is saying he's getting 3.9 exponent 4. Good. So this will be 3.9 exponent 4 Newton per coulomb. Then afterwards, you get your angle, and you say to get your angle, you get the tan inverse. Get the tan inverse of what you have as your EY divided by what you have as your EX. So the answer you get is your angle. But here you can do it in a good way or in a better way. But you can first sketch. So when I sketch, I'm getting something like this. Y, this is a negative, this is a positive, Y is positive, so this is 3.8640 exponent 4. Then this is negative, so I'll place here that this is negative. So, but there's no need to put in the negative because when you go back to your Cartesian plane, here, I know this is positive, I know here it is negative, I know here is positive, and I know negative. So when I place this is like your XY, your negative is going to be here and your positive will be here. So you get something like this. So when you draw, you're going to get an angle here. So that angle you're getting is what members are getting as 82.1 degrees. And it is because you have said tan inverse of EY out of X. So when you are stating your final answer, this one can be your direction. But those people who understand very well how to get the direction can as well go on and get the angle, this angle here, and get this angle here. That one is also very correct. If you get this angle here, it is also very okay. So when you are stating here, you will say that the magnitude of the resultant electric field intensity is 3.9 exponent 4 newtons per coulomb in the direction 82.1 degrees. Now here to bring out the idea very well, you will say above the negative horizontal. Above the negative horizontal. If you don't mention the word above the negative horizontal, you can as well say 82.1 with the negative 5.355 times 23 Newton force. That one can as well work. In case you don't want to use this option of stating the angle, then you get 180 minus 82.1, then you give that direction. All of them kind of work. Hope we are okay on that. Is that point fine?
Yes.
Okay. Can we move to the next thing? Okay. Now I want to give you some work. I want to give you some two numbers. Let me hope we have not left you and your sister.
Yes, teacher.
Are we still together or we are leaving you?
Teacher, we are together.
Okay. Now this is the question you people are going to try out. So these numbers I usually take 6 marks, 7, 5, but within that range. In case you find that your diagram is not labeled, feel free always to put some letters to ease your work. This is square root. So those are the two numbers that I want you to try out. But let me add another one. Just one more. Those are the numbers we are going to try out. I'm going to be opening that WhatsApp group at around 6 or 6:15 around that time. And then I'll ask you to post your work in the group such that we can discuss on which solutions we have obtained for each of those numbers. For you, just post your work, and then we shall be looking at each other's work, and then we make a comparison on what one person has posted and compared to what the other person has, and then we compare our answers. Have we finished, right? Oh, Riomi is not on the group. Oh, okay.
Excuse me, sir.
Yes,
Teacher, I'm having a question.
yes, please ask.
Teacher, what if the charges are in the same line?
Like
Yeah,
which one? Okay, ask him.
Yeah. Then you're asked to calculate the midway point. Or maybe you're given charge A, charge B, charge C. Then you're asked to calculate the electric field intensity over midway Q.
Okay.
Yeah, kind of. So how do you? Yes.
Okay. And you asked question the electric field what?
Intensity. Then they say between points midway. The question was kind of like that. It was saying calculate about the electric field intensity midway Q over between points midway Q.
Okay, okay. Let me look for something similar to that, and then I throw some light on it.
Okay.
Have
Thank
the
you,
members
sir.
finished? Has everyone finished writing their questions? Yes, Bujo?
Teacher, it's a question, eh? Are we allowed to write the directions as northwards, eastwards, westwards, northeastwards, or we are supposed to stick to what you've given us?
Okay, now, those ones, we mainly use them in math of mechanics, much as they are correct directions. So they will not pin you. But when it comes to north, let me say northeast, that one, you must stay, you cannot say northeast. Reason being, unless when you are sure that your angle is 45. So for those ones, you must state the angles, mainly for diagonal forces. You must state the angle at which it is at. So you don't say northeast what one, no. You must mention the angle. But northeast, westward, we mainly use it for math. And here we mainly use to left, upwards, right. But those ones are also correct. East, west, north, south, they're also correct. The right directions.
Okay, thank you, sir.
Okay. Members, have you finished? Write the questions.
Yes.
Okay. Okay. Those who have not finished, you can just take a screenshot. Done. Okay. Redmi, I've shared the WhatsApp link in the group. Now, Redmi, I think it was Redmi, they were asking, now when you check, they can give you points. They can say this is P, this is R, and this is maybe S. And then they ask you that 2-point charges, P and S, and then they can give you that maybe P is -7 micro coulomb, and maybe this is -9.0 microcoulomb, are placed in a vacuum at a distance of 21 centimeters, something like this. And then they say, when a third charge, R, is placed midway between P and S. Now, when they say midway, it means means like in the middle. That is the implication, that it is placed in the middle, such that this side is equal to this side. Now, in case it is 21 and it is placed midway, it means that from P, it is 10.5 centimeters. From S, it is also 10.5 centimeters. That is the implication. Have you understood that point?
Yes. So teacher, here we calculate considering the point R.
Okay, now it depends on the question, because now the question they were asking, determine here they wanted you to determine it. Now in case it is finding the electric field intensity at R, yes, then you consider R. So you say electric field intensity at R due to P, electric field intensity at R due to S.
Okay.
Then, but when you check the question bank, when you check 2005, they were asking them to calculate the charge on R, to find the charge, the real charge. Now, for such a case, now in case it is electric intensity, you do it the way we have been doing it. In case it is they're asking for the charge, because they can tell you that the net force on S is 0, determine the charge. Then that one, you use another approach. For that one, once they mention the net force, it means that is 0. It means that when you sum up all the forces acting towards that object, you get 0. So that is the implication. So that means if at all they say the net force on S is 0, that means you are going to find which force is acting on S. So you say force due to P and force due to R. Now, that means that the two forces, once you add them, are the forces acting on S. So that means that the force at SP and the force at SR, they are additional, the sum of these forces is equal to 0. So then you make your calculations. I don't know that is okay. Riomi, is it fine?
Yes, teacher.
Okay, I don't know that it's you who asked or someone, but the person who asked. So,
It's
but
me.
it's you, eh? Okay. So
Yeah.
you can try, take 2005, paper 2, question 10, eh? Part D.
Yes.
Yes, and try out that question. It has that concept of midway. Even the same thing they can tell you, they can give you this figure, and they tell you find maybe they tell you to maybe find something in the middle of the square.
It's in the middle.
Yes. Find the resultant force. So still you do the same, because they will give you a charge here, maybe 1. They give you a charge here, maybe 2. They give you a 3. They give you 4 here. So still you use the same approach. But now here what is very important is they are testing. Can this person calculate this distance here? Because they can say this is 4 and this is 3. So they are testing. Can this person calculate? Can this person not know that this is going to be 1.5 and this one is going to be 2? Can he be able to calculate this value here? Can he be able to calculate this distance here? Can he be able to calculate that distance? That is what we are testing you for. And once you pass that, that means you have you have passed. Is that okay?
Yes, sir.
Okay. So we shall start from there. We shall start from there. We shall start from that point when we meet again. I want to wish you a good evening. Let's discuss on the group after you have tried out those numbers. Have a good evening. Bye.
Likewise. Bye.
Okay.